or the screen is clear. Okay.
Yes,
Let,
sir.
Yes, sir.
just give me the confirmation regarding that, and we shall start the class.
Yes,
Okay.
sir.
Clear, sir.
Okay. Is the clear? Audio and the presentation is clear.
Yes, sir. Clear.
Yes, sir. Yes, sir.
Okay. Okay. So we'll take another 20 minutes to brush up the derivations. Okay. Should do it. And do not worry about the notes. Notes I will be sending in the form of the PDF. Later you can copy it. So I request all of you to pay attention for just next 15 to 20 minutes to understand this very important derivation regarding the van der Waals equation. Okay. Shall we start?
Yes, sir.
Okay. So in the previous class, all in the previous class, we discussed about the ideal gases. What are ideal gases?
Which obeys Gay-Lussac's law, Boyle's law, and
Charles' law. Okay.
yes, sir.
So the gases which obeys all the three laws, and even the PV is equals to MRT, which is ideal gas equation, is known as an ideal gas. And the gases which does not obey it eventually are the real gases. That means all the real gases existing in the nature are not idealistic. So that means the ideal gases never do exist in the nature, but the real gases tend to behave as ideal gases. I mean to say, they are just tending to behave. They are not ideal gases, but real gases at some circumstances, at some atmospheric pressures and temperatures, they will try to behave as ideal gases. That means at those points, the ideal gas equations gets tallied. And what is that condition was my question in the previous class. And even I have given the hint of this particular thing, which is HP and LT. So what are those conditions where your real gases will tend to behave as ideal gases? Yes. You can follow this hint, which says HP or it is LT. So these are the two conditions where your real gas, whatever the gas which is existing in the atmosphere, will behave as an ideal gas. Okay, so what are those conditions?
High pressure and low temperature.
Exactly, Sushant. So it is high pressure and low temperature. HP is the hint for high high pressure. Okay, and LT was the hint for low temperature. So at these two conditions, at a high pressure, high amount of pressure, and at a very low temperatures, your real gases will tend to behave as an ideal gas. Okay. See, this particular equation is there, right? Which is PV is equals to MRT. This PV is equals to MRT, which is an ideal gas equation, is derived by the kinetic gas energy theory, kinetic theory of gases. So this kinetic theory of gases you have learned in your second PU. There it comes in the chemistry subject, and you have derived this equation of PU is equals to MRT, most of you, I guess. And during that particular period of time, you might have assumed all these assumptions. Number 1, 2, 3, and 4. These 4 assumptions are the assumptions of the kinetic theory of gases through which you derived PV is equals to MRT equation. Let us go one by one. Can anyone read the first assumption?
A finite volume of gas contains large number of molecules.
Okay, the finite volume of gas contains large number of molecules in the sense. See, if this is a finite, this is a finite amount of volume for your study. For your study, you have fixed up this particular volume. Okay, In this volume, it says it has large number of molecules, so large that there is no gap between the molecules. That means it is completely packed. There is absolutely no gap between the molecules, he says. So such as assumptions made, but practically it is not possible because the molecules will move away from each other. There is huge amount of gap between the molecules. That was your first assumption. Second assumption, anyone? The second assumption,
The
Chirant?
collision of molecules with
Okay. Yes.
one another
Continue.
and with the walls of the container perfectly
Uh-huh.
elastic.
Perfectly elastic. That means uh, these molecules may collide with each other like this, correct? May collide with each other, or these molecules can collide with the wall like this. Ah, these two aspects of collision, number one and number two, both are assumed to be perfectly elastic. What is a perfectly elastic collision? Anyone knows about it? It's simple, right? If there is a perfect elastic collision, whatever momentum this particular thing has, the molecule one has, all of its momentum will be transferred to the molecule two. Okay, the momentum before collision and the momentum after collision will be equal. So when such momentum is equal, then it is known as a perfectly collision. So while they are in it, you have assumed that um, the collision between the molecules as well as the collision with the wall is perfectly elastic, which is not at all possible in the realistic in nature. Number three, Chirant.
Yes, sir.
Yes, number three assumption.
The molecules are separated by large distances compared to their own dimensions.
Mhm. Exactly. So when compared to their own dimensions, the molecules are separated to a larger extent because one of the theories says uh, the items and the molecules will touch each other. But in the gas thing, it is not possible. When you compare the radius of each and every molecule, it becomes much larger when it is compressed with the assumption number one, because it contains large number of molecules, there is no voids in it. That means your molecule has to overlap each other like this. Okay, if you go with the exact radius of molecule, that is not possible. Eventually, that assumption has failed. Number four, Malatesh. Malatesh. Marvin.
Yes, sir.
So, Marvin, can you just read out the fourth assumption? Marvin. Okay. Mohan. Mohan Chandra.
Yes, sir.
Can you just read out the fourth assumption?
The molecules do not exert forces on one another except when they are collide.
That is
Yes,
the
sir.
assumptions made, but okay, but according to the Newton's law of gravitation, any two substances, any two masses which has some amount of mass or weight in it, definitely will exert a force of attraction between them, which will be proportional to the product of the masses and inversely proportional to the square of distance between them. What is this law called? Anyone? Just a general knowledge question. What is just law called? Any two substances which has a mass will be attracted with the amount of force which is equals to F, and that force is proportional to the product of their masses and inversely proportional to the square of distance between them. Which law is this?
Newton's.
Newton's.
Gravitational law.
Exactly. So it is Newton's law of gravitation. So according to the Newton's law of gravitation, any two masses, any two substances, any two objects which has a mass, definitely it will experience a force of attraction between them. So that is the Newton's law of gravitation. But when you come for the molecules, when you come for the kinetic theory of gases, all the molecules in it, whether it has a mass or not, the molecules of a gas, whether it has a mass or not. Whether the molecule has a mass or not.
Yes, sir.
So molecules has a mass, is it? So when molecules has a mass, does the force of attraction between the molecules exist or not?
Exists, sir.
So yes. So if the force of attraction is being present between the molecules, you have assumed that what you have assumed, the molecule does not exert any forces from one another except when they collide. How is that possible? Because if the molecules do not collide also, each and every molecule will be attracted and experience a force of attraction between the other molecules. If it's collide also, if it does not collide also, it doesn't matter. But you have assumed as such because that's why this particular equation does not get tallied in every of the circumstances, in all of the circumstances. Okay. So any of the doubts in these assumptions? All the four assumptions?
No, sir.
No, sir.
Okay. Okay. So we shall move further. So in order to compensate the assumptions which are made in the ideal gas equation development and make it useful to apply for the real gases rather than the ideal gases, Van der Waal came up with an equation which is a famous equation, everyone must know it. It is P plus A by V square into V minus P is equals to RT. I want everyone to remember this particular equation. Just take 5 to 10 seconds to just mug up the equation. It is P plus A by V square into V minus P is equals to RT. This famous equation is known as the Van der Waals equation, where you have two different constants over here, A and B, which are known as the Van der Waals constants A and B, and these constants depend upon the type of material. That means if you go for the nitrogen gas, these constants would be of different value. If you go for another gas, the constant value for A and B would be different. Okay, and all these aspects we shall try to derive this particular equation, Van der Waals equation, and know what is the value of expression to calculate A, what is the expressions to calculate B, all those things we will just try to analyze now. Okay, the same equations can be represented in terms of the molar specific volume. Okay, in terms of the molar specific volume as such. The only difference you observe is when you replace the specific volume with the molar specific volume, what happens? Your gas constant will change into universal gas constant. That means the specific gas constant gets changed into the universal gas constant. So there are two forms of expressions here. The number one is P plus A by V square into V minus P is equals to RT. This is in terms of the specific volume. And the second equation is P plus A by V bar square into V bar minus P, that is equals to R bar T. So you can easily remember when there is a bar at the RHS, you will be even having a bar on top of your gas constant, which turns your specific gas constant into the universal gas constant. So remember these equations. Let us try to mug up this. Muhammad Khalid, can you just repeat the equation first form of the Van der Waals equation? Muhammad Khalid. Not there. Okay, Muhammad Khalid. Ritesh Kumar. Ritesh.
Yes, sir.
So Ritesh, can you just repeat the first form in terms of the specific volume, which is small v, van der Waals equation?
Small b.
Just repeat it, looking at the screen.
P plus a by v square bracket v minus b equals to
Mm-hmm.
RT.
Very good. Syed Anwar.
Yes, sir.
Syed Anwar. So give me the equation in terms of the molar specific volume, van der Waals equation. Give me the equation.
P plus A by V square into V
Not
minus
v
B equal
square. Be careful. It
V,
is v bar, not v. V bar
V
is
bar
molar specific volume.
into V bar minus T equal to R bar T.
Mm. T. Saurabh Shetty. Saurabh.
Yes, sir.
So repeat both the forms of the equation and specify all the terms in it. So you have to say what is P, what is A, what is B, what is R, and what is T. Okay, both the equations. Come on, quick. Be quick, Saurabh. Okay, Siddesh PN. Siddesh.
Yes, sir.
So repeat both the equations, specifying each and every term. First, say me the complete equation. Later, tell me what is P, what is A, what is B, what is P, what is R, and what is T. Similarly, go with the other one. Make it fast, Siddesh.
P plus A divided by V square into V
Mm-hmm.
minus B is equal to RT.
Mm-hmm.
V is
Okay,
equal
what is P? What is P?
to pressure.
Okay, P is pressure. Next, what is A?
Uh, becomes
A is van der Waals constant. What is
Van der Waals
A?
constant.
Okay, what is V? Small v.
Specific volume.
Specific volume. Very good. What is B?
Is B spec-
B is also a van der Waals constant.
Van der
Remember,
Waals constant.
Siddesh, A and B both are van der Waals
Van der Waals
constants.
constant.
Okay.
Okay,
Okay.
sir.
Now, what is R?
Universal gas constant. Partial
A.
specific gas constant.
Siddesh. Then what is R
Specific
dash?
plus a specific gas constant. R.
R is specific gas constant. R dash is universal gas
Universal
constant.
gas
Remember
constant.
this. Now, what is T?
Temperature.
Temperature.
Temperature. Very good. Now, go with the second equation, Siddesh. Okay. What
P
is second
plus A,
equation in terms of the molar specific volume?
P plus A divided by V dash square into V dash minus B is equal to R dash T.
R dash T. So what does P? You have said, yeah, I got to know. And what is this V bar?
V bar molar specific volume.
Molar specific volume. Very good. So what is R bar?
Universal gas constant.
Universal gas constant. And T is your temperature. So everyone got
Temperature.
the equations? Both the equations? Any doubts in this?
No, sir.
Universal.
No, sir.
Okay. So we shall try to derive these equations. So questions. Okay. There was a picture. Yeah. So in this ways, your question might be asked in your examinations, guys. The number one is evaluation of critical properties, derivation of van der Waals equation in terms of critical properties, derivation expression for critical pressure, critical temperature, and critical volume in terms of Van der Waals equations, Van der Waals constants, A and B. So in these three forms, he might ask, and all the three forms will account for the same derivation. So we shall just look into it, how it does, okay? Now, Van der Waals, once he says all these questions, we have to start with the Van der Waals equation. So Van der Waals equation is P plus A by V square into V minus P is equals to RT. To find the constants of A and B, what happens, now we should look into this particular diagram. So this particular diagram is the PV plot of a pure substance. Okay, we will study this in very detail when you come for the pure substances. Now, how much is required? That much I'll just say you. Okay, this is the saturated liquid line. Okay, all of you are observing it.
Yes, sir.
So
Yes, sir.
this is your saturated liquid line. Next, this is your saturated vapor line. Okay, this is your saturated vapor line. Okay, got it. Now beyond this, whatever is there, I mean to say all these things, guys. Now I'm plotting it up now. So all these things is a liquid portion. So all liquid exists here. Liquid, 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 liquid. Got the things? Now, apart from this, when you trace all these terms here, here and all your vapor exist. Vapor, 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 vapor. Okay? And the third, between the saturated liquid line and between the saturated vapor line, all liquid plus vapor. So both the things exist here, liquid as well as vapor, liquid as well as vapor. Both the things exist. Got the meaning? Okay. So all here, which thing exists? Omar, in this region which I have just shown you, what exists here? Omar.
What's your question again?
So the region which I have just highlighted onto your screen, uh, whether liquid exists there, whether vapor exists there, or liquid plus vapor exists there.
I think vapor exists there.
No, only liquid exists there. Pay attention, guys. On all this region which I have just marked here, what exists? Pratik, Pratik KC.
Yes, sir.
So what exists here? Liquid, vapor, or liquid plus vapor?
Don't know, sir.
Kale or class Kale or Pratik. Here the class. Pradeep
Yes, sir.
Shetty. Pradeep Shetty. Pradeep.
Yes, sir.
What exists here, which I've just highlighted?
What, sir?
Whether here liquid exists or vapor exists in the portion which I've highlighted just now.
Vapor.
Vapor, very good. So in this region, what exists?
Liquid.
In this region,
Vapor, sir.
oi,
Both, sir.
very good. In this region, liquid plus vapor, both the things exist. Okay, keep this in mind. Okay, now listen here. And this particular aspect, I can say two things I have to just highlight it upon. The critical point. This critical point is the point where your saturated liquid line as well as your saturated vapor line coincide. Okay, what is critical point? What is critical point,
Saturated
guys?
liquid line and saturated vapor line coincide.
Saturated vapor line will coincide. At the point at which this saturated liquid line and the saturated vapor line coincide is known as a critical point. Okay. At this critical point, the first and second derivative with respect to V will be 0. That means dou P by dou V at critical point will be equal to 0. See, in the sense it is at critical point. This is the first condition. The second derivative of this will also be 0. That means dou square P divided by dou square B at critical point will be 0. Okay, just remember this. At critical point, what happens? Number one condition is the first derivative of P with respect to V at critical point is 0. Number two is the second derivative of P with respect to V at critical point is 0. That means you have to differentiate this particular value of P. So you can take this van der Waals equation. Okay, shift this V minus B to the either side. It will come at the bottom. Here V minus B like this. Plus A by V square to the either side. It will be minus A by V square, V bar square, which I have just written here. Got the meaning? So I have just taken P on the LHS. Everything else I have just pushed it to the RHS. So it forms my equation number 1. Now it's time to differentiate this so that I get dou P by dou V. In order to get dou P by dou V, whether in which derivative I have to differentiate this, whether I have to differentiate with respect to V or whether I have to differentiate with respect to T. The equation number 1, in order to get the value of dou P by dou V. I have the expression for P here. With what respect I have to differentiate the expression of P here.
V.
Exactly. So we have to differentiate with respect to V. So when you differentiate with respect to V, what is d by dx of x to the power of n? It is n into x to the power of n minus 1. As that similarly, when you differentiate, you will get dou P by dou V is equals to minus R bar Tc divided by V bar C minus B whole square. Why? Because see, here it is VC, V bar at the bottom, is it? When you take V bar at the top, what happens? It is V bar to the power of minus 1. What is V bar to the minus 1 differentiation? Minus 1 V bar into minus 1 minus 1. So it will become V bar minus 2. When you take it to the denominator, it will be 1 by V bar square. A simple differentiation, guys. Got this? Got this, everyone?
Yes, sir.
Yes, sir.
So similarly, so it will be V bar minus B whole square. And similarly, when you differentiate the other term, it will be 2A divided by V bar cube. See, because here it was V square, V bar square. When you take it to the numerator, what would be? V bar minus 2. When you differentiate this, what happens? It is V bar minus 2 into minus 2 minus 1. So it is minus 2 into V bar cube. Yes or no? So V bar minus 3 here. So when you take it to the denominator, it would be V bar C cube. So when you differentiate dou P with respect to V at critical points, all the critical point values you have to take. That means your T will become Tc, your V bar will become V bar C. Okay. Similarly, when you equate this to 0, for the first condition was what? Dou P by dou V will be equal to 0. You have differentiated this and you have equated it to 0. Take the value of R bar into Tc. Okay, in this expression, what you have to do? You have to take the value of R bar into Tc. Rest all you just transfer to the either side. Rest all you just transfer to this either side, you'll get this particular expression. R bar Tc is equals to 2A divided by V bar C cube into V bar C minus B whole square. Take this particular equation as number 3 here. Now, when you want dou square P divided by dou V square, what you have to do? You can differentiate dou by dou Vc of dou P by dou Vc, is it? So once you have already differentiated this particular thing, again, if you differentiate this particular thing with the Vc, you'll get the second derivative, which is dou square P divided by dou V square. Similarly, differentiating this again will lead to this. Okay? There is a simple differentiation, man. Again, should I explain it once again, how this differentiation has been obtained? Does it require?
Yes, sir.
Okay, fine. So here it is. So minus R bar Tc divided by V bar C minus B, its whole square, plus 2A by V bar cube, V bar C cube. So this is what? This is dou P by dou Vc. Now, if I want dou square P by dou Vc square, that is what? Dou by dou Vc of dou P by dou Vc. Okay, so dou P by dou Vc is here. I can just write it as dou by dou Vc of, what is dou P by dou Vc? Is this particular expression, minus R into Tc divided by V bar minus P, its whole square, plus 2A divided by V bar C, its whole cube. Okay, now differentiating this again with respect to Vc. What happens? So minus R into Tc, I'll just take it out. Now V bar C, if you take it to the numerator, it will be minus V bar, just a minute, adjusting. Okay, now R into Tc, when you take this particular thing to the numerator, what it will be? It will be V bar C minus P whole to the power of minus 2, correct? I'm just concentrating on the first term first. Okay, is this correct? I'm taking this V bar C minus P to the numerator, so it will be V bar C minus P minus 2. When you differentiate this particular thing, we'll go at a stretch, just a minute. Okay, now, so plus, you can take 2A as common. I mean to say it is a constant, right? So it is V bar C. You when you take it to the numerator, it will be minus 3. Now, I have to differentiate this particular thing with respect to Vc again. Okay, when I differentiate this particular thing to Vc, what happens? Minus R into Tc. What is x to the power of n d by dx? Differentiation of x to the power of n. What is the differentiation of x to the power of n?
nx.
N? nx?
To the power of n minus 1.
Exactly. So same thing I'll be doing now. So d by dx of r into t is, however, it is a constant. So v bar minus b whole to the power of minus 2, in the sense I can write it as minus 2 into v bar c minus b whole to the power of minus 2 minus 1. Correct? Can I write it as such? Any mistake in doing so?
Correct, sir.
Okay. Similarly, I can write here as plus 2a into minus 3 into Vc minus 3 minus 1. Okay? So that is equals to, again, minus RTC into minus 2 divided by, so V bar C minus P whole to the power of minus 2 minus 1. Can I just replace this by, can I just replace this by minus 3 here, like this? Minus 2 minus 1 is minus 3, correct?
Yes, sir.
Yes or no? So I can take this V bar minus P whole to the power of minus 3 to the denominator, so it would turn V bar C minus P just 3 here when it turns down to the numerator. Now here in the other term, here it is what? 2 into 3. 2 3s are 2 3s are, guys.
6.
Very good. 6a. So here you have a minus sign. So I can just okay, put it into the minus here. So minus 6a into, see, Vc to the power of minus 3 minus 1. How much?
Minus 4.
Minus 4.
So when I take that Vc to the power of minus 4 in the denominator, can I just write it as Vc to the power of plus 4 here?
Yes, sir.
Yes? Okay. Now, so I'll just put form into the neatly, okay? Minus into minus plus here, so 2r bar Tc, 2r bar Tc divided by Vc minus P whole cube minus 6a divided by VC, V bar C. I have missed the bar everywhere, man. You have just put bar there. Okay. So it is 2 R bar TC divided by VC minus B whole cube, because minus into minus, this minus and this minus will become plus, and this is the expression which is just written here. Where it is, man? Here it is. So this expression is this expression. Okay? Understood? Any doubts? Just a differentiation then. Shall we move further?
Yes, sir.
Yes, sir.
Okay. Just log this on. Okay. Now, next. So, you have come up with equation number 3, which you have got while differentiating in the first derivative, that is dou P by dou VC. You have come up with equation number 4, which you have got by differentiating it twice, that is the second derivative. So, in the both expression, you have extracted the value of these two expressions, that is R bar TC. See, when you compare the equation number 3 and the equation number 4, the LHS is common. Yes or no? The R bar TC, here also it is R bar TC. So can I equate? That means if LHS is common, can I equate both the RHS?
Yes,
Can
sir.
I do so?
Yes, sir.
So since LHS is same for both the things, I can equate the RHS. So RHS of the first expression is this, and the RHS of the second expression is this. Got the meaning how it has been written here?
Yes, sir.
Okay. I want answers from everyone, man, so that I get confirmation that everyone are listening. Okay. So when you equate this, we'll start to simplify all the aspects. Okay. When you just simplify, like see, when you just simplify this, so here it is VC cube. Here it is VC to the power of 4. So it cancels, only VC remains here. Okay, and VC minus B whole square, here it is. Here it is VC minus B whole cube. I can cancel VC minus B whole square and cancel here VC minus B whole cube, so that only VC minus B remains here. Okay, so whatever is remaining, I have just written here. Again, A and A get cancels. A getting it or not, man. See, in these expressions, which are the terms I can cancel, man? In this equation,
A.
VC minus B.
A I can cancel. Okay,
Yes,
A I will cancel first. A I have cancelled. Next, what can I cancel?
VC minus B whole square.
So VC minus B whole square, I can cancel it, so that your 3 goes away. Only VC minus B
1.
remains. Next, what else can I cancel? Apart from Aditya. Apart from Aditya.
VC bar
What
cube.
can I else cancel?
VC bar cube,
Yes.
sir.
So VC cube I can cancel here. So 4 goes away. That means 3 minus 4. 4 minus 3 is 1. So only VC remains. What is remaining? I have just written here. Okay. So 2 is remaining. Okay. 3 here is remaining. Okay. 3 have written here. VC have written. VC minus B have written. Any doubt here?
No, sir.
Any doubts?
No doubt, sir.
Okay. So fine. Multiply this term with both the terms. Okay, 3 into V bar C into V bar C. What happens? Your V bar C and V bar C goes away. And 3 into V bar C into B is your second term. In these terms, which is common, guys? I am now asking in this particular equation. I have cancelled VC. Which is common?
3.
Which is common? 3 is common. So I can take 3 common. Okay. And simplify further. So it is 3 minus 3 divided by V bar C into B. I can take it common, or else I can just send this 3 to the either side, where it becomes 2 minus of 3, that is equals to minus 3 divided by V bar C into B. Yes or no? 2 minus 3 is minus 1, and the remaining expression he has just written here. So in this, can I cancel minus here and minus here? Can I cancel?
Yes, sir.
Yes, sir.
So finally, what you will get is V bar C is nothing but your 3B. Okay, got up till here?
Yes, sir.
Any doubts up till here?
No, sir.
Yes, sir.
No, sir.
So continuing further, so further, whatever you do is just simple, man. You take once you got the value of V bar C, you will take equation number 3. Where is equation number 3? This is your equation number 3. In this particular equation, you know the value of V bar C. How much it is? 3B. You just substitute 3B here and whereas 3B here. And go on solve further. Go on and solve further. You will get the expression for TC. Okay, you'll get the expression for TC. It's just a simple mathematics, man. Do I need to explain it detailing once again?
No, sir.
Yes or no? Just
No, sir.
what you have to
No,
do,
sir.
you have to take equation number 3. You have to take equation number 3 and you have to substitute the value of VC as 3B. Okay, just substitute 3B here, 3B here. Just go on solving it. Your B cube and B square will get cancelled. Only B will remain, A will remain in the numerator, and you'll get this final expression. So by this, you have calculated V bar C and even the TC. Substituting V bar C. Now, what all you have calculated, by the way? Let me just list out. You have calculated V bar C, which is 3B, and you have calculated the value of TC, which is 8 by 27 A by B into 1 by R. All this expression you have to remember. Anyways, I will teach you how to remember this. Okay, so you have calculated V bar C as well as the value of TC here. Now, you have to take this V bar C and TC value which is calculated and substitute in equation number 1. Where is equation number 1, by the way? So here is your equation number 1. So before differentiating, so why are you doing all this? So when you substitute the value of TC and when you substitute the value of V bar C, just I have highlighted it. Okay, when you substitute the values, you'll get the value of PC. So same thing he has done here. What he has done, he has substituted the value of VC. He has substituted the value of TC, so that if you solve this, okay, if you solve this all this for mathematics, you'll get this expression for the value of the PC. So the PC value you can calculate it as PC is equals to how much here? A divided by 27 P square. So the value of PC, TC and VC is calculated as so and so. 3B is for VC, 8 by 27 A by B into 1 by R is the value of TC. A divided by 27 into B square is your value of PC. Okay, once you calculate the value of PC, VC and TC, you know that VC is equals to 3B, so B can be VC, but you need to calculate the expressions for A and B one. It's very simple. So VC is what? VC is 3B, correct? So when you want B, it is what? It is VC divided by 3. That's it. So B value is straight away given as VC divided by 3. For the B value, you can take PC expression. PC expression is this particular thing here. PC is equals to A divided by 27B square. You take this expression and substitute the value of B and B, just to substitute the value of B. So you can cancel here. So 9 ones are 9 threes are. So whatever you remain, you'll get the expression for A also. So at the final outcome of the derivation, you have to remember only these 5 expressions. Okay. Number 1 is, I'll just erase this all. Oh shit. Number 1 is the expression for the critical pressure. Number 2 is the expression for the critical volume. Number 3 is the expression for the temperature, critical temperature, expression of A, expression of B. So all these things you have to remember. By the next class, everyone has to say me. I'll be asking individual wise, what is the value of PC, BC, TC, A and B. So these are very, very important for the problems if you remember this, plus the van der Waals equation, and how to use the compressibility chat, which will be taught in the next class. Your problems are almost done. Okay. Any doubts in the derivation, guys? I've just picked up some textbook because he has very neatly described, neatly, elaborately presented. Okay. Any doubts in this derivation?
No, sir.
No, sir.
Understood, everyone?
Yes, sir.
Okay.
Yes, sir.
So Saturday, the first hour will be of BTD, right? Saturday first hour.
Yes, sir.
Yes, sir.
Yes, sir.
So there will be no class on that day, Saturday first hour. Okay. So directly there will be a long gap after this. Preferably it will be on Monday again. Not Monday again. Monday you don't have a
Tuesday,
class of BTD because
Tuesday,
So
sir.
Saturday
Tuesday.
holiday.
Saturday ಎಂತಕ್ಕೂ holiday?
ಅದು ಕೆಲವ್ದು ಕ್ಯಾಲೆಂಡರ್ ಅಲ್ಲಿ ಇತ್ತು ಸರ್.
ಏನಕ್ಕೆ ಹಾಲಿಡೇ ಅಂತ ಹೇಳಿ ನಂಗೆ ಫಸ್ಟ್. ವಾಲ್ಮೀಕಿ ಜಯಂತಿದ.
birthday, sir.
ಹಾ
That's why.
ಸರ್.
ವಾಲ್ಮೀಕಿ ಜಯಂತಿ ಕೊಡಲ್ಲ ಕಣ್ರು ಹಾಲಿಡೇ. ಓಕೆನಾ? Friday is holiday. Tomorrow is holiday, I guess. No classes will be taken. Okay. So we'll be having a long gap. After this, we'll be meeting on again. When?
Monday.
Tuesday.
Tuesday.
Tuesday, sir.
Mandala. Tuesday. So give me your attendance, guys. Okay, be fast. Abdul Rahim. Abdul Rahim.
Present, sir.
Akash. Akash. Be fast, man. Akash. Akash. Not there. Akash.
Present, sir.
Sir, Akash present. I just mistakenly ended the call.
Okay. Bharatish. Bharatish.
Sir, Akash
Okay.
present.
Akash.
Present, sir.
Bharatish. Mark Devarsh.
Present, sir.
Present, sir.
Present, sir.
Okay, pa. Okay. Harshit.
Present, sir.
Okay. So if you know the order, you can. Oh no, marks.
Present, sir. Present, sir.
ಏನಕ್ಕೆ ಅಷ್ಟು ಟೆನ್ಷನ್ ಆಗ್ತೀರಾ?
Ashit, present,
Oh
sir.
no, done, Harshit. Marked it. So if you know the order, you can just put the message in the
Ashit,
chat
present,
box.
sir.
Harshit. Okay, pa Harshit. Mark ಮಾಡಿದ್ದೀನಿ ಕಣ. Hashir, yes. Hazim, yes. Srijan, yes. Kiran Kumar, not there. Kishan, yes. Lucky there. Malatesh there. Melvin there. Muhammad Khalid. Okay, Mohan there. Munawar. Lucky there. Okay, Lucky mark ಮಾಡಿದ್ದೀನಪ್ಪ. Okay. ಒಂದು ಸರಿ ಕಳಿಸಿದ್ರೆ ಸಾಕು. Muhammad Suray. Next is Nishan. Nitesh. Okay, Nishan is there. Okay, Numan. Pradeep. Praveen. Pradeep is there. Praveen. Praveen. Right. Okay. Raj Prasad.
Present, sir.
Mohammed Sarai. Where were you, man? Raj Prasad. Rajat. Okay. Rakesh GM. Syed Anwar.
Present.
Where? Syed Anwar. Hey, give me the order, man. Ramachandra. See, once your preceding guy has put a message, you are able to see it, right? So once he has put a message, you can put a message, unless and until wait. Okay. Ratak. Ratak. Praveen Suryakant. Hello, Ideshnatu. Okay. Next, Ratak logo. Done. Next, Syed Anwar. Done. Next, Sohan. Okay. Siddesh PN. Yes. Okay. Saurabh Shetty. Yes. Next, Srinivasan, not the Stephen. Stephen. Stephen, yes. Sujan, yes. Sushant. Sushant. Hey, Narendra. Taado, ನಿನ್ನ ಹೆಸರು ಬಂತೇನೋ ಇಷ್ಟು ಬೇಗ ಸುಶಾಂತ್ ವೈಭವ್ ವೈಭವ್ ಓಕೆ ವರುಣ್ ವಿಘ್ನೇಶ್ ಓಕೆ ನೆಕ್ಸ್ಟ್ Marvin. Okay, Bain is there. Marvin. Swaroop.
Present, sir.
Okay, Marvin is there.
Sir, Marvin present, sir.
Okay, pa. Darshan SST is there. Mandan Karthik is there. Next is Prakhyat. Prakhyat. Praveen Nair.
Sir, present, sir. Present, sir. Sir,
Prakhyat.
Prakhyat.
Abdul Sami.
Sir, Saturday class I was present, sir.
Okay. Okay. Abdul Sami.
Saturday class I was present, sir. You told
Okay,
me
I
to
have
give my...
marked you present man. Prakhyat.
Abdul
Praveen.
Sami present, sir.
Abdul Sami. Aditya Shetty. Amal PK. Amok Hekate. Yes. Chandan Rav. Chirayu. Yes. Saral Vikas. Yes. Darshan Shetty. Yes. Midlaj. Yes. Narendra. Yes. Amar. Yes. Pratik. Pratik. Okay. Yes. Rachan. Ritesh and Vishnuraj. Okay. Rachan R. Shetty. Yes. Ritesh. Yes. Vishnuraj. Okay. Pa. Take care. Have a nice day. Okay.
Thank you, sir.
Yeah.